Take a valley, broad and gentle. Stretch it from the highlands to the sea. Cover it with green grass, dense forests, lush fields, and great pastures. Cloak it with natural beauty. Build cities and towns along the wooded slopes, and you have the Valley of the Mississippi, the greatest in the world. This is the Valley of the Giant. Our nation is drained by many large streams, but the largest by far is the Mississippi, the outlet for water from an area of 1.25 million square miles. The Mississippi drains water from 31 of the states and 2 Canadian provinces. Waters from West Virginia, Wisconsin, and Wyoming all find their way to the Mississippi, winding their way through the alluvial valley, an area subject to floods without protective engineering works. This valley begins just below Cape Girardeau, Missouri, and extends to the Gulf of Mexico. The lower Mississippi carries the combined discharge of the Missouri, the Ohio, and the upper Mississippi. And in the lower valley, the waters of the St. Francis, the White, the Arkansas, the Washita, the Red, and the Yazoo. From rivulets and creeks, from brooks and bayous, the waters come, flowing into larger streams. Down these into the Mississippi in a headlong rush to the sea. South from Cairo, past Memphis, Vicksburg, and Natchez. Past great steel bridges linking the east with the west. South past Baton Rouge to deep water. Down the Great Valley to the port of New Orleans. Through the passes to the sea. In its peaceful moods, the Mississippi is a thing of beauty. This is the river of Mark Twain, the paddle wheel steamer. The river of the keelboat and the log raft. This is the river of romance, of laughter, and of tears. For the last way. For the last way. Even today, the slap of paddle wheels can be heard over the broad waters of the river. And, too, you can hear the steady, powerful thrum of twin-screw diesels. Today, the Mississippi carries more peacetime tonnage than ever before in her history. From Cairo to Baton Rouge, the products transported by water each year would fill more than 300,000 freight cars. And each year, between New Orleans and the mouth of the passes to the sea, enough tonnage is moved to fill a freight train almost 6,000 miles long. The Mississippi is one of the most important of our national assets. The strong arm of a widespread inland waterway system connecting the Gulf of Mexico with the upper Mississippi, linking the Great Lakes to the seven seas. During the war, the existence of this waterway made it possible for us to build fighting ships hundreds of miles from our vulnerable oceanside shipyards. Maintenance of a safe navigation channel is a big job. Upriver, dustpan-type dredges are used to remove dangerous sandbars. These giant machines help keep the channel open so traffic can move in safety. From Cairo to Baton Rouge, a 9-foot depth has been maintained, and a 12-foot depth is authorized for deep draft barges and steamers. A depth of 35 feet is maintained at all times from Baton Rouge to the Gulf of Mexico so that deep draft ocean vessels can make an easy passage to the lower river ports. On the lower river, cutter head dredges work around the clock and 365 days a year, digging and pumping, eating away great mouthfuls of dirt, cutting and filling, changing the river's course. Produce and manufactured goods consigned to all parts of the world pass through the busy ports on the lower Mississippi. Because of the open channel, great ships move downriver, bound for Antwerp and Naples, London and Liverpool. Because of safe navigation, long tows travel along the broad Mississippi and its many tributaries. Iron and steel southward from the east and Midwest. Salt, sulfur, and petroleum products north to the great markets of the Midwest and the east. But sometimes the giant gets out of control. Sometimes the rich valley lies helpless, defenseless against great floods which leave terror and destruction in their wake. Rainstorms to the north, to the east, to the west, and the waters of the swollen tributaries rush to join each other at the head of the valley. "1912, 1913, 1922, 1927. Yes, 1927. Then the giant stormed down the valley in his greatest fury. Crops could not be planted. Bewildered livestock sought refuge on untopped parts of the levee. Scores of lives were lost. Rail transportation was disrupted. Highways and bridges were blocked off. Thousands of people were left homeless and destitute. Refugee camps were established to cope with this national disaster. In response to this crisis, the Congress of the United States passed the Flood Control Act of 1928, an act which was designed to permit the federal government to unify the control programs which had already been undertaken. The Army engineers were instructed to develop and put into effect an overall plan for controlling the floods which, for years, had been stripping the valley of its great wealth. The broad flood control plan was no overnight accomplishment. It took years of careful planning and exhaustive investigation. Specially trained engineers mapped and studied the Mississippi and its tributaries, measured the valley of the giant for size, and cut the control pattern accordingly. The program is based on a flood greater than any the valley has ever known, greater than the record flood of 1927. Let's superimpose this flood on the valley and see how the engineers plan to take care of it. Here are the features of the master plan. Thousands of miles of levees have been built, long earth walls along the stream to hold back the overflow. Dams have been built, giant bulwarks to hold floodwater until it can be safely released. Floodways have been built, auxiliary channels to divert water flow when the giant storms down the valley again. To align the channel and to help lower flood stages, cutoffs have been made. And where the river is migrating dangerously, revetments have been laid to protect farmlands and threatened levees. In the great alluvial valley, flood control reservoirs have been built. Others are under construction on tributary streams. Today, the Mississippi has been walled in by levees. The West Bank levee line begins just below Cape Girardeau, and except for gaps where tributaries join the main river, extends unbroken almost to the Gulf of Mexico. The East Bank is protected by levees alternating with high bluffs. Diversion of excess flow is provided by the Birds Point, New Madrid floodway, the Bonnet-Carré spillway, and floodways in the Atchafalaya Basin. These are the essential features of the master plan. 3,500 miles of levee have been built along the Mississippi and its tributaries. A big job, and one that requires much more than merely piling up earth. Samples of the soil on which the levee will rest are taken by field parties and brought to the district soils laboratory for analysis. Here, delicate machines measure the physical properties of the soil. Each of the samples is analyzed. The results are compiled and studied, allowing the research engineer to pass on valuable information to the designers. In the field, the site is surveyed and staked. Then bulldozers clear the way for the levee, felling trees, grubbing stumps so that bigger machines can go to work. Drag lines are widely used, especially when the borrow pit is located close to the levee embankment. Tower machines are used where the borrow pit is some distance from the embankment. Uncompacted sections such as this are typical of levees constructed immediately after the passage of the 1928 Act, when speed and quantity were the governing factors in building levees. These machines can dump 20 tons of dirt into the levee in one load. Farther away from the scene of actual construction, drag lines dig dirt from selected pits and load hauling equipment. The hauling equipment moves continuously from pit to levee and back again. At the levee site, the wagons dump their load, 40,000 pounds each. Then the big bulldozers dress the newly deposited fill to the design form. This is the way levees are built today, where compaction is the prime factor. During construction, engineer survey parties check the work to make sure each phase is finished to conform with contract specifications. And high standards are required. Sodding the slopes with tough Bermuda grass is the final step. It prevents erosion. This grass grows quickly and forms a protective cover against high water. Mark Twain called the Mississippi the crookedest river in the world. And crooked rivers mean high flood stages. Navigating these bends is slow business for water as well as for boats. In the early 30s, the engineers began a systematic straightening of the river. 16 cutoffs were made between Memphis and Baton Rouge, and 170 miles were cut out of the river. This new channel was straighter, and the flow of water through it was straighter, with the result that the flood crest at Arkansas City was lowered by 14 feet. But all it required digging, and lots of it. And the best way to loosen soil is to blast it with dynamite. Monitor jets are used to wash down material from the bank. This makes the dredging job easier. dredges work in pairs while making a cutoff, working through the neck of land toward each other. The dredged material is carried through a long, flexible pipeline to a point well downstream. At the other end of the cut, the other dredge eats its way through, working steadily toward its mate. The cut is not carried completely through. A small section called a plug is left in place. Later, when conditions are right, the plug is blasted. The higher water above the gap flows swiftly downstream. The banks of the pilot cut are quickly eaten away, and the river soon adopts its newer and shorter course. The Mississippi is a meandering river. Meandering rivers cave their banks and present a menace to nearby levees, farms, and industrial areas. These caving banks present the engineer with one of his most perplexing problems. The soft soil through which the Mississippi flows is easily eroded, allowing the river to migrate in long loops through the valley. In the lower valley, revetments are used to protect the levees. The first step in revetment construction is to grade the rough bank with drag lines mounted on barges. The bucket digs into the steep bank and flattens its slope, carrying the material down into the stream. When the rough operation is completed, more machines begin the final grading operation. In many cases, revetment extends several hundred feet into the stream. A 4-inch gravel blanket is placed where the bank is subject to wave action. This prevents leaching of soft clay and silt through the revetment. The revetment itself is made up of flexible mat sections. Modern production line techniques are employed. The first step is to lay down a paper separator. The wire mat acts as a reinforcing fabric. Then slotted steel forms are laid, and the fabric is drawn up into the slots, and the forms are locked. Before concrete is poured, the forms are sprayed with oil to keep them from sticking when the concrete's removed. Here is an open-air assembly line, a fleet of mixer trucks which moves down the forms, filling them with concrete. Men follow the machines to finish the sections. Each man on this job walks 10 miles during his 8-hour day. The finished units are then stockpiled in the field and left to cure. From the field, the revetment units are carried on barges to the site of revetment construction. Here, they are assembled on the platform of a sinking barge. Cranes lift the units and swing them onto the waves. Then the workers slide them on rollers into the required position. Each unit is securely attached to its mate. Then the entire section is launched to form one continuous mattress. The concrete mattress extends from slightly above the waterline beyond the deepest part of the channel. In many cases, these revetment mattresses are more than 600 feet long. When the protective mattress has been lowered to the river floor, the cables are cut. Then the assembly barge moves upstream to place a new section. This is a highly specialized operation. It requires special equipment, which can only be used in this type work. Much river work is done by private contractors under the supervision of the Engineer Corps. But this operation is done by the Corps itself with hired labor. Paving of the upper bank begins when the underwater part of the revetment has been laid. A mixture of asphalt cement and sand is normally used for this purpose. A belt conveyor carries the asphalt cement sand mixture from the floating asphalt plant to trucks on the bank. Then the trucks move away to dump their loads into steel sleds. These are then pulled up the bank, leaving behind a layer of uncompacted sand asphalt. This blanket, overlapping the concrete mattress, completes the revetment, which is now ready to help guide the course of the river. And so, the master plan goes forward. In the spring and fall, when the giant river awakes to begin its headlong rush to the sea, these massive walls will stand as a bulwark to protect the valley. Agriculture will flourish unharmed, and the people of the valley will prosper. Cities, formerly ravaged by flood, will grow stronger under the protection of the great levees. and industry can now safely bring its factories to the banks of the river. And so the future becomes one which holds new promise for the valley and the nation. The giant is being harnessed, slowly but surely.